Alright, we're going to graph the function and find its x and y intercepts. The function we have here is a line, so y equals negative 3/4 x minus 6. The negative 3/4 is its slope, and the negative 6 is its y-intercept. So we can start there with the y-intercept and graph it. And then the slope says we can go down 3, to the right 4, or we could go up 3 to the left 4. And then we'd probably want to do that one more time until we cross our x-axis. And then to graph, we're just connecting those points. You may want to use an actual straight edge. We'd get something like that. Now the question here is, what are the x and y intercepts? Well, we have x-intercepts. This is when the graph will cross the x-axis. This happens at an x value of negative 8 and a y value of 0. And for a line in slope-intercept form, it gives us the y-intercept, that is 0, negative 6. Looking at another function to graph the function and state its x and y intercepts, we have the function y equals 1/2 times x plus 3 squared minus 8. This is a quadratic. We know that because it is squared. It's going to make a U shape when we get around to it. On graphing quadratics, it's most often helpful to think about its vertex. So we have y equals a times x minus h squared plus k. For our graph here, since we have x plus 3, that means we have a negative h value, because if you were to subtract a negative, you get a plus 3. So we have negative 3 for our h value, and our k is negative 8. So we would go and graph that point, negative 3, negative 8. And then we might pick some points on either side of that x value. So with the x value of negative 3, we might decide to go in and look at negative 2. So what happens when x equals negative 2? So again, this is just 1 to the right of negative 3, the other x value that we found already. We would have y equals 1/2 times negative 2 plus 3 squared minus 8. And that is 1/2 times 1 squared minus 8 equals 1/2 minus 8, which is negative 7 and 1/2. So since we filled in negative 2, that means the x value is at negative 2. And again, our y value at negative 7 and 1/2. So negative 2, negative 7 and a half, negative 7 and a half. So here, again, next we might pick a value that we know is going to work well in the function. Since we're multiplying the squared part by 1/2, we might try to make that even always, which means that we always want an even number on the inside to square it to get another even number. So a number that might work better would be to fill in odd. If we look at x equals negative 1, y equals 1/2 times negative 1 plus 3 squared minus 8. This would be 1/2 of 2 squared minus 8. 2 squared is 4 times 1/2 is 2, so we get 2 minus 8, which is negative 6. Negative 6 and negative 6. Again, we have symmetry here. So we might keep going and looking for other ones that work well, or we can just keep picking values. We probably wouldn't stop here yet because we don't have our x and y intercepts, so we should still pick a few more values. So since we're looking for the y-intercept, we might use x equals 0. Y equals 1/2 times 0 plus 3 is 3 squared minus 8. That is a half times 9 minus 8. Half of 9 is 4.5 minus 8, which gives us negative 3.5. So that's the point 0, negative 3.5, which means we also get the point negative 6, negative 3.5. And if we go one more, so we might check out x equals 1, we get y equals 1/2 times 1 plus 3 squared minus 8. 1 plus 3 is 4, and 4 squared is 16, minus 8. Half of 16 is 8, minus 8 is 0. So when we plug in 1, we get a 0 out. And since we have symmetry, the same thing is going to happen at negative 7. And so we get a graph that looks something like this. It says to state the x and y intercepts. So we get x-intercept, and we actually have two of them. We have one at 1, 0, and another one at negative 7, 0. Again, this is where it crosses the x-axis, that is here and here. And then we have a y-intercept. There's only one of those, that's where it crosses the y-axis, which we did find right here as well. Y-intercepts happen when x is 0. So this is the point 0, negative 3.5.